All right, y'all. Today we're going to focus on how to be able to identify some of these characteristics of a histogram. Now, if you remember correctly, we did this last week when we focused on 6 main characteristics: the shape of a histogram, the modality of a histogram, the center of the histogram, identifying the range, and then also if there's outliers or gaps. So the first thing I'm going to do on this histogram is I'm going to go ahead and I'm going to estimate the frequencies for each column. So in my opinion, this frequency reaches 23 for our first column. I'm going to do the same for the other columns. So 25. It's a little bit less than 23. I would probably say 21. In this case, maybe about 14. This is the same height as that, so 21. Both of these would be the same as that 14. This one coming over, maybe about 7. This one, based off of what I have, a little bit less than 5, probably 4. This one I'm going to call 1, and I'm going to call this 2. And that's going to come in handy when I'm talking about my center that we'll refer to here in just a second. Okay, so now let's talk about the shape of this data. If you recall, there was 3 different shapes that we had. We had symmetric data, we had skewed left data, and skewed right data, and we decided that based off of the look of our histogram. So in this case, our histogram does seem to have a tail. We have a bulk of the data that's right here, and we seem to have a tail of the data that is to the right of the graph. And so since our tail is to the right of the graph, then our shape is going to be identified as skewed right. If the tail was on the other side, we would consider it skewed left. If we couldn't identify a tail and our data was the same on both sides, then that's when we're talking about our data being symmetric. All right, move on to modality. So let's go ahead and erase this. And we'll talk about modality. So modality also refers to the shape of the graph, but it refers to this idea of how many modes that you have. Remember, we had 3 different options with modality. It was either unimodal, symbolizing that there was 1 mode, bimodal, symbolizing that there was 2, or multimodal, symbolizing that there was 3 or more. And so in this case, in my opinion, because we can see that there's 1 hump right here, I'm going to consider this to be unimodal. Now, we've spoken about justification, and I think that some people might be able to make a justification that there's 2 humps in this case. So if you saw that your data had 2 humps, meaning that it declined and rose in between these 2 21s, in that case, I think you could justify it being bimodal. But for our purposes, we're going to consider that unimodal. I see this as going up, coming back down, and since these right here share the same height, it's almost as though it keeps on going back down. So in my opinion, I would call it unimodal, having 1 mode. The center we're going to come back to in just a second. So let's skip the center for right now, and we'll move on to the range. Now, range is really similar to what we've already dealt with range as far as a biggest number to a highest number. If we look at this histogram, each of our columns represent 50, an interval of 50. We have 100 to 150 to 200 and so forth. And remember that these are symbolizing beginnings. So in this case, even though this 600 is at the end, we have another column that's extended further than that. So I'm going to go ahead and write a 650 at that point, just to remind myself that that is not the end. The 600 is not the end. It actually extends further beyond that. And that's going to help us with our range. Our range is going to go from this 100 to this 650. And in this case, because we're talking about histograms, and histograms do not talk about exact values, I'm going to go ahead and leave that range as it is, 100 to 650. I know in the past we've subtracted to get a single number, but I'm going to leave it as a range of numbers from 100 to 650. Okay, now let's move on to outliers and gaps. If we recall, Outliers are going to be data points that are far, far away from the bulk of our data. Back in 10th grade, we learned about standard deviation, and we had more of an exact definition of outliers. For our purposes with histograms, we're just going to focus on the fact, is our data all together? Is there a piece of data that's far, far away from everything else? And in this case, a bulk of our data is all in one spot, but all the rest of the data is connected to it. And so I'm going to consider that there's no outliers. The next step is gaps. Now, these gaps that we're looking for are a little bit different than gaps in the data, right? We talked about histograms have to show continuous data, meaning that these columns have to be pushed up next to each other. However, what would happen if we had a zero frequency? Say, for instance, instead of a 1 right here, if this was a 0 and we didn't have any data in that spot, we would still have to represent it in order for us to be able to have continuous data. However, we would leave it with a blank, and we would leave the same width of space as what we did for this 4 or for this 7 or for this 14 and so on. And so that would represent a gap if this was a frequency of 0. However, since all of our columns have frequencies of 1 or more, then I would consider that we have no gaps as well. Okay, the last section, the center. The center is probably the most difficult part to be able to look at because it's not just simply looking at the data that they give you. You have to do a little bit of calculation. In this case, what I'm going to do, since I've already have all of my columns labeled as far as the estimates that I presume those to be, I'm going to go ahead and add all those together. So in my calculator, if I were to add 25 or 23, 25, 21, 14, 21, 14, 14, 7, 4, 1, and 2, we would end up getting 140. So I'm going to write that down right over here. If we're wanting to find the middle of these 140 data points, that literally means that we have 140 representations that are all on this histogram, 23 of them being in this column, 25 in this column, and so forth. But we have 140. If we want to find the middle of those representations, we need to be able to divide by 2 to find the halfway point. So if I take the total amount of frequencies and divide it by 2, I'm going to get 70. So this is like my target. I'm looking for where the 70th dot is going to be. This is what I want to know. And so I'm going to continue and go back to these. I'm going to look back at my frequencies and I'm going to figure out, well, where is that target data point? So in this case, I have 23 data values in this one column. Now in the past, we've showed these with checks, and we could go ahead and put 23 checks to represent the 23 data points. However, I think it's a little more time consuming than necessary. So what I'm going to do is I'm going to think about, will that 70th data point fall in that column? If I have the first 23, we know that the 70th data point won't fall in there simply because it's 23. However, to figure out if it's going to fall in the next column, I would have to add this 23 and this 25 together, giving me 48 to be able to test and see if it's in this column. Since the first 48 would be within those two columns, we know the 70 is not there. I'm going to continue and do it with the third column as well. 23 plus 25 plus 21 gives me 69. That means the first 69 data points are in those first three columns, but that's not our target. Our target is 70. And so therefore, we know that the 70th dot, the 70th data point has to be in this one column. And so our center is going to be in that column. In this case, when we represent a center, similar to how we represented a range, we're going to go ahead and we're going to show that as a range of numbers. We don't know exactly where the center is. We just know that it's somewhere in here. Notice that this goes from 200 to 300, but we leave this spot out. So I'm going to go ahead and mark that spot as a 250. Sometimes I think it would be a good idea if you didn't see these marked with numbers to go ahead and put those. But in this case, I'm only going to identify this one. And the reason why is so I can identify where that 70th dot would be. That 70th dot is going to be in between 250 and 300. Now, last thing I'm going to mention. When we talk about these ranges, in the past, when we talk about our histogram, we've talked about these dots representing the beginning point of the histogram, which is accurate, which means that technically this 200 is the beginning of this column. It's not the end of the previous one. So I could see where people would make an argument that this 300 should not be included in the range for our center. However, I'd rather use the 300 than use, say, 299. Reason being is that if it's continuous data, we could have 299.99, and then we could go even further than that. So to make it simple, I'm going to go ahead and represent this center with that range of 250 to 300, and I would accept if you did the same as well. So this has been just a kind of a review over how we use histograms, how we can find these 6 characteristics of histograms with shape, modality, center, range, and whether or not they're outliers or gaps.